So Brandon Richards, I'm the general manager for APAC, or Asia for Neo4j. And I've been with Neo4j for 6.5 years, which in the startup world is a very long time. So I was the first Asia employee here. But before I get into graph data platforms, I wanted to share something about something special about Mumbai. And Mumbai actually has a key piece in this graph data platform creation and the whole space. So our founder and CEO, Emil Ephraim, was on a flight from Copenhagen to Mumbai when he had a napkin and he started to draw out what has become known as the labeled property graph. And that basically has started the entire graph movement. So he got off the flight, he started talking to a friend, and that was the birth of graph data platforms. So Mumbai has a special place for those of us in the graph space. So in the context of when I talk about graph data platforms, I have to give a little bit of context to what I mean by the word graph. So graphs, when we're talking about graphs, it's a network of interconnected things. So when we're talking about graphs, we're not talking about charts or visualizations. We're talking about networks, connected networks of things. So it's mathematical graph theory, right? How things are connected, how they're related, and I want to understand that. So we live in a connected world. Everything around us is connected. If you think of atoms connected to other atoms or molecules, right? Neurons connected to other neurons are in our brain. Human connections, we have networks of families, networks of friends, networks of colleagues, social networks, right? These are all connections of things connected to other things, right? Things connected to other things, Internet of Things, right? Another example, we have devices that are now all connected to each other through the internet. We have road networks, train networks, the way we schedule our flights. All of these are networks. Supply chain networks, which is particularly important here in the retail room, right? How our supply chains, if you can think of a supply chain as one thing connected, we use the word chain to describe them, right? It's this long chain of things that are connected. So these are all graphs. Anything that's connected in a way like this is a graph. So how do we represent this connected data? Well, we got all of our smartest geniuses together in humankind, and we figured out we're going to represent graphs like a spreadsheet. I don't know how we came up with this, but rows, columns, tables, this is how we're going to represent our data. Now, as a part of this process, we actually lose something. We lose the richness of the context and the relationships when we do this. Now, we also, so the things that we're losing relationships, we're losing context around things, and the insight that we can gain from that context. So again, if we go to our SQL guru in the company, they say, don't worry about it. I know how we can connect these tables. We'll just create an index to connect them. And using an index to connect them was a fantastic way of connecting data when we have these disconnected tables. The problem is that for highly connected data sets, they don't scale. They just don't work. And so I've used this image of index card. And I don't know how many of you are old enough where if you went to the library as a young child, I can see some, when you were trying to find something, you would go to these index cards. And I would say indexes in our table join indexes are kind of not too far off from index cards. All right, it's old tech. So graph data platforms, coming back to what I'm talking to you about, graph data platforms is this breakthrough in technology and how we deal with connected data. So we can now store data as a graph. We store the relationships in the database when we write to the database. We can visualize the graph, and so we can see what these actually look like in a visualization form. We can query the graph. I didn't have that in here, but you can query the graph as well, just like you would any other database. But one thing that's unique about graph data platforms, all other data stores, you can store information and then you can retrieve that very same information. But with graphs, one of the things that's unique about graphs is I can store information and then I can query information that I didn't actually store, which is really kind of unique to graph data platforms. We can also run graph analytics. And this is, graph analytics aren't new. We've had the ability to do that, but to be able to do it at scale, at any kind of a reasonable amount of performance was previously unattainable. So what we find is, using that index-based approach of the past, we could do what we would call up to 3 hops. So it's kind of like 3 degrees of separation. I could do queries that were within that, and it was still okay. If it's more than 3 hops, it would degrade exponentially, the amount of time it would take. So we've designed our queries around these constraints. We've designed how we interact with our data around these constraints. And part of the benefit of graph data platforms is we can now toss those constraints out to the side. The key benefit is because we're storing these relationships with the nodes in the graph, we don't have to calculate that when it's time to query. We simply follow these paths. So it doesn't matter if it's 3 hops or 3,000 hops or 3 million hops. I can do that in milliseconds. So that's really exciting. Everybody wants faster, but really the value that's derived from a graph is that now, because of that performance and because it doesn't really cost me anything to add more complexity to my queries, I can now start to do some really interesting things with my data. Firstly, I can start to ask much more interesting and sophisticated questions of my data, the kinds of questions that were just previously impossible. I can start to do things in real time that used to be batch processes. So if you can think of, in the retail space particularly, I need to make supply chain decisions right when something happens. And if I have to wait for a few hours, maybe that could be a problem. Maybe that's okay. But if I have to wait weeks, if I have to wait for someone to manually process this, that's a real problem. If I can get that in real time, I can make decisions that are very impactful for my organization. Now, data science, it turns out that when you have this connected foundation of contextualized data, that I can actually start to run data science on it, and it turns out that I get much better outcomes from my data science when I have this contextualized, connected graph as a foundation. I can actually start to leverage relationships in my predictive models. And if you think about one of the things that I mentioned before, one of the things you gave up when you were using joins is that you lost this relationship data. And if you think of how much value there is in the relationships in the data, very often the relationships are even more valuable than the actual discrete data themselves. So now we actually can leverage relationships in our predictive models, and it can become really powerful in our outcomes. And this has really taken off in the last couple of years. So it's interesting, Gartner has said that 1/2 of all the inquiries they get about machine learning and AI are about how they can leverage graph in machine learning and AI. And I think 1/2, that's a big percentage of people. So it's getting really exciting in that space. The fourth thing that graphs do is allow me to future-proof my applications. And what I mean by that is when you're dealing with traditional data stores and traditional data platforms, you create this schema up front that's very rigid. And if you want to make adjustments, then it trickles down it cascades across the schema into a major effort. With a graph, if I want to change my schema or my graph model, I can do that in seconds or minutes. So the application of that is if I have evolving business requirements, And we see this happen a lot. Businesses, especially in retail, things are happening very quickly. So as I have these evolving business requirements, I can make adjustments and be ready to go. For example, I have new data, new type of data I want to ingest into the graph. No big deal. I can change my graph model and I'm good to go. Or if I have new questions I want to ask of my data that I didn't think about when I was designing my schema, again, not a big deal. So as you could probably imagine, we get rid of these kinds of constraints, and it's a little bit like a race to value. Who can leverage this to the maximum value in their industry the fastest? Who can do it before their competition catches on? We see this in several different ways. So one of those is data-driven discovery and innovation. So ultimately, people are, one of the areas is kind of unstructured data. We've got all this unstructured data. How can I actually get value out of my unstructured data? This is being used by organizations like NASA, right, where they have the International Space Station, and they're trying to figure out, for every astronaut that goes up there writes up a report, a very detailed, meticulous report of everything about that space station. And they can take this unstructured data and start to identify trends, solve problems. They can figure out what they can do to make predictions about what's going to happen. So that can become very powerful. Hyper-personalization. I think I heard that quite a bit in our last panel discussion, talking about personalization. This is huge, right? If I need to gather all the data I know about my customer, for example, and be able to personalize in the most advanced way possible so that I can give them the very best experience. If I'm using old data approaches, I'm going to be limited in how I can do that. Basically, remember those 3 dimensions that you're limited to, or maybe 5 or 6 if you're using batch processes, that's a strong limitation. When we use personalization, we can do thousands of hops, right, as a part of that. So that gives us a strong advantage. So recommendation engines is a huge area where we're seeing graphs being used. Personalized healthcare is another example, but this could be, I want to understand the journey that our customers are taking, and maybe I want to understand the journey of our very best customers. And when I understand the journey that our very best customers are going, then I can start to analyze what are those inflection points where maybe I can hit somebody who's maybe at a similar early stage to ensure that they become more like my best customer, right? So there's a lot of that that's happening. Enhanced decision making, and this would be automation in a lot of our processes. So we want to, they use fraud prevention as an example. I need to be able to detect if there's a particular pattern of fraud or one of these 8 patterns of fraud in less than 4 milliseconds so I can act on it, kick off a workflow. Network analytics, so this would be things like, oh yeah, you see that in cybersecurity threats, things like that, but it could be network issues, any of that. I want to be able to figure out what the cause of my problem is and stop it. Massive data integration, so this is kind of that idea. I want to pull data from across all my different silos and pull them together in a single view, like a complete view of my customer, a complete view of my product, complete view of my supply chain. So all of these are the ways that I can start to integrate and connect the dots across the data. And as an example, if you had, how many different systems do you think you have in your organization that has customer data in it? And my guess is if you have a large organization, it could be hundreds of systems or thousands of systems. To be able to pull all of that and get a complete coherent view of everything is very powerful. I don't know if that's telling me I'm out of time, but Gartner, last 3 years in a row, have called out graph as one of their top 10 trends in data and analytics. And what's really interesting is if you actually go through those reports, they're talking about graph throughout the entire report, not just in the graph section. And so I've got a couple of quotes. One is, using graph techniques at scale will form the foundation of modern data and analytics. The foundation of modern data and analytics. I think that's really powerful. The other one from the 2021 report is that graphs relate to and enable many of our current and past trends, including, and they start listing off some of those, data fabric, natural language processing, the rise of the augmented consumer, X analytics, smarter, more responsible, more scalable AI. So graph is kind of like that super trend. It's the trend in data and analytics that will allow you to do all of the other things you want to do in data and analytics. You have to have that first contextualized, connected foundation. It probably wouldn't surprise you to know that 7 of the top 10 retailers in the world are using graph. In fact, using Neo4j to drive business value. Now, almost every single one of those is using not just one use case, they're using multiple use cases. They are leveraging this to gain an advantage. And so some of those use cases, we've got knowledge graphs. So a knowledge graph is I want to pull all that data I know about a particular thing into one single coherent graph, add some, enrich it from external sources. I might want to add things like some structure with ontologies or taxonomies. So that's one big way. But that knowledge graph becomes the foundation of a lot of the other things you want to do. Maybe that knowledge graph will power recommendation engines or promotion engines, dynamic pricing engines. We see this in hospitality, organizations like Marriott, who want to be able to have their pricing change in near real time based on market conditions. Or ATPCO, right, which is airlines. If you've bought an airline ticket in the last several years, almost certainly Neo4j was the engine that determined what you paid. So this is very powerful. Entity resolution. We all have entity resolution problems in our data, but this can be very powerful as a process in things like recommendations. I want to make a better recommendation if I know that these two people that I thought were separate individuals are in fact the same individual. That can help me give a better recommendation to them. Same thing for fraud detection. Supply chain analytics. We've seen supply chain problems, especially in the last couple of years with COVID, the chip shortage, the blockades and, or the Suez Canal getting blocked up. This is huge. Getting insight and visibility into that can have a huge impact. Customer journey analytics, I've already talked a little bit about that. Logistics, a lot of the big logistics companies in the world are using Neo4j for routing optimization, ensuring that they can get things done very quickly. Digital twins, that can be very powerful for organizations that want to create a digital twin of something real, a product sometimes. And of course, I've already talked about data science, AI, and machine learning. My last comment is Forrester did a total economic impact analysis of customers who use Neo4j for their graph data platform. And among other things, they said that those who invest in a graph data platform with Neo4j are getting over 4x back, over 400% return on that investment within 3 years. And they also pointed out that that is excluding all kinds of other benefits that they've seen in the organization that they didn't quantify. So I hope, I'm out of time, but I hope that this session has been interesting and opening up your eyes to what connected data can offer for your organization. And if you're interested, we have a booth right here in the back. If you want to know about any of those stories that I didn't get time to go into Walmart and Marriott and JCPenney, Meredith, really interesting use cases. If you're interested in understanding how they're using graph to the greatest potential, come back to our booth. We can walk you through it. And I hope this was helpful to you. Thank you very much.